Hello, my name is Hasmi Raizan bin Hamsi and my matric number is 104334. So this is problem statement in our project. Moisture and humidity issue. Traditional wardrobe often lack proper ventilation, leading to the build-up of moisture, which can result in mold, mildew, and unpleasant odor on clothes. Next, temperature fluctuation. Without any temperature control, wardrobes are susceptible to external temperature change, which can cause damage to duplicate fabric over time. Next, lack of air circulation. Poor air circulation in conventional wardrobe can lead to stalled air, contributing to musk, smell, and reducing the freshness of stored clothes. Next, indicate storage for different seasons. Traditional wardrobe may not accommodate different storage needs throughout the year, such as keeping winter clothes dry and fresh during warmer months. Next, space inefficiency. Many older wardrobes are not designed with modern space optimization in mind, leading to inefficient use of available storage space. And lastly, material deterioration. The absence of humidity control can accelerate the deterioration of material like leather, wood, and curtain textile stored within the wardrobe.
Hello, my name is Ethan Hadian Aston, number matrix 105350. Next, we will present about problem analysis tool, cause and effect chain. First, they didn't manage their clothes, traditional wearables, goes to busy. The reason next is too much commitment. Next is lack of priority and poor time management. The outcome if didn't organize your clothes and shoes efficiently. Distraction. For poor time management, didn't have time to maintain shorted, clean clothes, and overloading the wearable with unfolded clothes.
Hello, my name is Liu Yiling. Today I want to present function analysis. Main function of wardrobe straw cron. Shift, organize, folder cron. Hanging row support hanger with cron. Drawer contain accessory. Door protect contents. Handle facility door open. Material sub provided structural strength. Structure maintain whatever design. In interaction analysis, material joint, door joint, drawer joint, handle joint, structure, and support wardrobe. Material joint soft and soft joint, hanging row joint, structure, and support wardrobe. Material also can straightforward joint, structure, and support wardrobe. In this interaction analysis, air influence structure, gravity pull structure.
Next is function model. Shelf, useful or normal. Folded clothes. Hanging rod, useful, insufficient. Hanger with clothes. Drawer, useful, excessive, accessories. Doors, useful, normal, contents. Handle, useful, normal, door opening. Material, negative, harmful. Structure, strength. Structure, negative, harmful. Wordable design.
Assalamualaikum, my name is Muhammad Shami bin Masra and my car metric is 105285. Okay, today we're going to talk about our problem solving tools and contradiction if then but. Firstly, problem solving tools, trimming. First, the main useful function of a wardrobe is storing the clothes. Second, function analysis of a wardrobe function. Material can support structure, structure can support wardrobe, and wardrobe can store clothes. Third, we use perform trimming. Rule C. Some component does not use in this function. So for our trimming, we will not use structure. So it will be material can support wardrobe and wardrobe can store clothes. For our contradiction, if, then, but. If the clothes won't dry, then the level of heater can be adjusted, but consume more electric energy. Improving parameter, number 17. Worsening parameter, number 21. Inventive principles, number 17, 21, 35, and 38. Principle explanation, number 35. Parameter change. Change the object or system to inventing something new as it physically state. Number 38. Strong oxygen. Collect air and transfer it inside the object to create some heat. Last but not least, number 17, another dimension. Multi-story arrangement of the object instead of single-story arrangement. That's all for me. Thank you.
Hello, my name is Nathaniel Adina Langston. Number matrix 105350. Today I would like to talk about multi-screen, as you feel, and this and S-curve. First, multi-screen. As we can see, our bus supersystem is hydropower, bus system electric, bus system subsystem is coil heater. Our present supersystem is magnetic field, present system hot air ejector, present system subsystem is thermal heater. Our future supersystem is electrolysis. Future system is ventilation system, and future subsystem is smart heater. Here's some explanation. For past, we shown that the power that needed to generate the system. For present, hot air ejector required less power because it projecting natural air surround as a cooler. Future, smart heat sensor make easier to dry the clothes and saving the time as the system can be set by the user manually. So next is as you feel. Our substance is wet, heater, and ventilation, or field, thermal, and mechanical. First, our problem model is S1, wet, make our S2 clothes wet. Our strategy 1, heater S2 goes to thermal F1 to heat wet S1 to make our clothes dry. Our next strategy 2, S3 ventilation out of our system. S2 heater goes to thermal F1 goes to wet S1. Our strategy 3, ventilation. S3 go to mechanical F1 produce a wind to make our heater coolant. S2 heater goes to thermal F1 heat our S1 wet. Our strategy 4, heater plus ventilation system. F2 mechanical make our S2 heater coolant as a ventilation. F1 thermal heat S1 wet. So basically,
substance and field operational zone, the most important elements are defined and represented as substance field model.
Next is T and S curve. As it shows on the curve or graph,
There's a substance image that labels as a pass, grow, mature, and feature. Those are evolution of wardrobe. So pass, limited space and for hanging clothes. Growth, as a door that can be closed to prevent foreign objects from damaging the clothes. Mature, has bigger space but stiff build. Feature, has heater and ventilation system built in, as we talk about our project. Thank you. That's all for me.
My name is Yong Wei Jie and my metric number is 104744. My part is to introduce the innovative function of the wardrobe heater. Traditional wardrobes, due to insufficient ventilation and temperature control, make clothes highly vulnerable to dampness and mold. The wardrobe heater effectively resolves these issues. When paired with a ventilation system, the wardrobe heater can dry clothes efficiently. Once the devices are turned on, the heater raises the temperature inside the wardrobe, accelerating the evaporation of moisture from the clothes. Meanwhile, it can reduce the humidity within the wardrobe. In humid environments, it prevents the growth of mold and safeguards the clothes. The heater and the ventilation system work in tandem to create an ideal temperature and humidity environment for clothes, extending the lifespan of garments, especially those made of delicate materials. Moreover, this heater is designed with energy efficiency in mind. It offers excellent performance while consuming less power. By analogy, the cooling system in a computer, which prevents components from overheating, is similar to the wardrobe heater that keeps clothes from getting damp. The heating system in a greenhouse, maintaining a suitable temperature for plant growth, is akin to the wardrobe heater maintaining an appropriate environment for clothes.
Hi, my name is Stephanie Ting. My metric number is 106444. This is our conclusion for Smart Drying Wardrobe project. A wardrobe with a built-in heater and ventilation system provides a comprehensive solution for clothing care by maintaining an optimal internal environment. The heater works to reduce humidity, which is crucial in preventing moisture buildup that can lead to mildew and unpleasant odors. This feature is particularly beneficial in regions with high humidity or during colder months when dampness can accumulate. The integrated ventilation system enhances air circulation within the wardrobe, ensuring that fresh air constantly replaces stale air. Thus, this continuous airflow helps in maintaining a balanced temperature and further reduces the chances of moisture retention. By circulating air effectively, the ventilation system also prevents the buildup of dust and allergens, keeping clothes cleaner and reducing the need for frequent washing. Together, these systems create a controlled microclimate inside the wardrobe that protects delicate fabrics from damage caused by excessive moisture and poor air quality. This is especially advantageous for storing seasonal clothing or items made from sensitive materials like wool, silk, or leather, which require specific conditions to stay in good condition. Moreover, a wardrobe with these features can add value to the home, offering a modern and innovative solution to traditional storage problems. It not only extends the lifespan of garments, but also enhances user convenience, providing a low-maintenance, efficient way to care for clothing. Overall, a wardrobe with a built-in heater and ventilation system is a practical, luxurious addition to any home, ensuring that clothes remain fresh, dry, and ready to wear at all times. That's all for our project. Thank you.